Okay, so looking at what we're looking at today, we are looking at absolute value. And in order to understand this well, it'll probably be best to go back to the two different ways that you were probably taught absolute value. The first is the geometric definition, which absolute value is defined as the distance away from zero on a number line. For example, if I ask you, what is the absolute value of -4? Geometrically speaking, you would draw a number line, you would plot the number 0, and you would plot the numbers until -4, and you would count how many units from 0 to -4 there exist. So there would be 1, 2, 3, 4. So our answer would be 4 units, which means the absolute value of -4 is 4. Do you guys remember that? Hopefully, you guys saw it in geometry. Absolute value is the distance away from 0 on the number line. Now, after you know that definition well, you can really transfer to the algebraic component, and your teacher probably told you, hey, do you notice that if there's just a single number inside the absolute value, a shortcut way to answer this question would be just make it positive? It's probably another piece you've been taught along the way, but really understanding both of those definitions today will help in solving equations. So now let's go to the algebraic component. If I ask you, what's the absolute value of 2? What would you say? 2. If I ask you, what's the absolute value of -3? What would you say? 3. Therefore, if I'm asking you to solve for x, and you have to find the value or the values of x that make this equation true, you could lean into your geometry definition and say, what numbers on the number line are 3 units away from 0? What would be your answer? Nice, 3 and -3. And that's the key for solving equations that involve absolute value. Whatever's on the inside, in order to solve, you have to take into account that there's a positive direction from 0 on the number line and a negative direction. And that kind of brings us into solving various types of absolute value equations. The steps are here off to the side. Number 1, make sure that that absolute value is by itself before you set up a plus or minus situation. But once it's by itself, then you're going to set whatever's inside equal to the number and the opposite of the number. Don't change what's inside the absolute value. All right, let's take a look at number 1. Number 1, if I have the absolute value of x is equal to 4, to solve this, I have to take into account 2 directions away from 0 on the number line and show that x could equal 4 or x could equal -4. And those would be my 2 answers. One thing I like to think about, so you guys hear me when I'm talking to you, ask you what undoes something a lot. For example, I'll ask you, what undoes addition? What would you say? Subtraction. What undoes multiplication? What would you say? Division. What undoes a square? What undoes a cube? Cube root. So what I'd like you to think now is what undoes an absolute value? 2 equations or 2 components, because there's 2 distances away from 0 on a number line. So the way to get rid of an absolute value is to set up 2 equations, or as we move into inequalities, you'll set up 2 inequalities. Now let's talk about what those would look like. One would be x minus 2 could equal 4. The other one would be x minus 2 could equal what? -4.
So this kind of the thing where like we would separate and do like, oh, it equals 0 versus it equals, like the 2 branches like equaling 0. Is it kind of like that?
Equaling 0.
So it would be the parentheses.
Oh, like factoring. Yeah, it's similar to that. Absolute value, you need to take into account 2 situations. And then we'd solve for x. So we'd add 2, and we get x is equal to -2. Add 2, and we get x is equal to 6. How could I check these? Good, plug them back in for x. So if I plug in -2, what's -2 minus 2? -4. What's the absolute value of -4? 4, so it works. If I plug in 6, what's 6 minus 2? 4, what's the absolute value of 4? 4, so they both work. They should both work as long as you've done your algebra correctly. Number 3 is a little bit different. What do we have to do first in number 3? Add 3. We need to isolate the absolute value before we can really get rid of it. So I'm going to add 3, which would give me the absolute value of 8 minus 3t is equal to 1. Then I need to solve for both, but this time I'd like you to turn to your partner and let's do the person with the longest hair in the partnership. You turn and tell your partner what 2 equations you would set up. Michaela, I think that's you for Caleb. Can you tell him what you'd set up?
I do 8 minus 3 equals -1, 8 minus 3.
Nice. I'm going to write down what she said.
Yeah.
All right, guys, check up here. Did you say, person with the longer hair, that 8 minus 3t should equal -1 and 8 minus 3t should equal 1? Awesome. Okay, so now let's solve. We would subtract 8, which would give us -3t is equal to -9. Divide both sides by -3. What happens when you divide a negative by a negative? Positive. Good. So we're going to get t equals 3 for one of the answers. And then on the other side, subtract 8, we'll get -3t is equal to -7. Divide both sides by -3. What's negative divided by a negative? Positive, so we get an answer of 7/3. Or you could call that 2 1/3, yep. And if we check them, they should both work out. Okay, the next thing we're going to look at is solving absolute value inequalities. When you think of the word inequality, you want to think of less than or greater than symbols. To determine the answers for these, I want to take us to just a simple absolute value inequality. The question asks, graph all the solutions for the absolute value of x has to be greater than or equal to 3. We know this is going to be on a number line, so go ahead and draw your number line. And we know absolute value deals with distance away from 0. So right in the middle, go ahead and mark in 0. Now, I want to read this as if I was your geometry teacher. Some of you are more visual minded. If I'm answering this geometrically, I would say, tell me all the numbers, because that's x. In other words, I'd say shade all the numbers whose distance is bigger than or equal to 3 units away from 0. Let me say that again. Shade all the numbers whose distance is greater than or equal to 3 units on the number line. Okay, on your own, go ahead and shade. I want to walk around and see how you guys think about this. All right, guys. Here's what I'm seeing. The easier way to think about this would be to start with the number like 3. 3 definitely works because the absolute value of 3 is 3. 4 definitely works because the absolute value of 4 is 4. 5 definitely works. The absolute value of 5 is 5, and all of those values are bigger than 3. The harder direction to sometimes think about is the negative direction. Weston, what else did you have shaded? Nice. He had -3, he had -4, he had everything to negative infinity shaded. If we think about why Weston's answers do work, you're shading the answers that make this true. And if I think about the number -4, the absolute value of -4, what does that come out to equal? 4. Is that greater than or equal to 3? Yes. So -4 should be shaded. It should be an answer. Now, graphically, this is what your answers will look like. We are going to be solving a lot of these algebraically. So my answers, if I didn't have them graphed, would look like this. I would say x has to be greater than or equal to 3, or x has to be, and I'm going to purposefully put this in a different color, less than or equal to the opposite of 3. Mario.
So with the green on top of -4, it was greater than 3. But if 3 was negative, it would also work. Right?
Yeah, -3 would also work. That's why it's shaded. Good. Because if I put in like -3, that would work too. That would still be.
On the right side. What
Um,
the actual 3 is.
Yep, 3 would work.
Okay.
The absolute value of 3 is greater than or equal to 3. Everything shaded should work.
Saying if the 3 was negative, sorry.
Oh, if the 3 was negative,
Yeah.
then the entire number line would work because everything would be bigger than a negative value. Yes. Okay, looking at the next one. Now, I'm going to ask you to just think graphically for a moment. Can you list all the values of x, or can you shade all the values of x that would make this true? If I'm speaking geometrically, I would say your answers have to be smaller than or equal to 3 units away from 0 on a number line. Go ahead and shade. Draw your number line, and let me see how you shade. I'm going to do a quick walk around again. All right, guys, I'm seeing really, really good things. Katie, can you tell me what you had shaded? Ooh, I love what she said. She said, and. She had everything from -3 and everything less than 3. Awesome. I saw a lot of you guys have this shaded, which is great. Now let's put our answers in the same way that we did before. So in this case, I would say my values of x have to be less than or equal to 3. And I'm going to use Katie's word. And the values of x have to be greater than or equal to the opposite of 3. Now, remember what I said earlier on. When you need to solve for x, so when you need to undo the absolute value, you have to set up 2 equations, or in this case, 2 inequalities. I want you to see some consistencies between the question and the answer. If I look at the first question, you're asking, what are all the values of x that make this true? Notice on the right side, I just took away the absolute value, and I see the values of x have to be bigger than or equal to 3. If I look at the one below it, if you're asking what are all the values of x that make this true, on the right side, we said the values of x have to be less than or equal to 3. So it had to match almost exactly what was stated without the absolute value. Now let's look at the other inequality. I've purposefully made those signs different. What do you notice is consistent in the original question and the answer of the other inequality? So here it's saying, what is the answer for X? What happened? And look here, it's asking what's the answer for X and what happened? What's getting flipped? Caroline? The sign's getting flipped and there's a negative. So to set up the other direction, you're going to flip the inequality symbol and make the actual number negative, because this one's dealing with the direction away from 0 in the negative direction. The only other difference is this one up here was an or situation, and this one was an and situation. And you guys know from yesterday's lesson or from Tuesday's lesson, or and have different meanings. Caleb.
So to clarify, and is like, you like stop at each point, and
Yeah.
or is like drawing.
Yes. And means they have to make both true, or means it could make one or the other. Good. All right, so let's take a look at the rule after we kind of walk through that preliminary step. So absolute value inequalities can be rewritten using the following properties. Here's how I remember if it's going to be an or versus an and situation. If it's a greater than symbol, I know it's going to use the word or. If it's a less than symbol, I know it's going to use the word and. Here's the property written below. This is copied from a textbook. You're going to notice that this one here, this is a greater than symbol. I would say X is greater than. And you're going to notice that therefore there's an or in between the two. The next one is a less than symbol. I add the word, or I add the letter D to it to help me remember this is going to be an and situation. Other than that, it's exactly what we just saw. To determine the solutions for X, you're going to take the exact inequality, remove the absolute value for one set of solutions. And then for the other solutions, you're going to flip the inequality symbol and flip the sign of the number. And this is going to be for both cases. So for the less than situation, I'm going to copy exactly what I see for one set of my answers, and the other set is going to flip the sign, flip the sign. I've had some students tell me like, oh, I just think of it as when you divide by a negative, you have to flip the inequality symbol. And I thought, hey, that's a great way to think about it. The other set is negative, so flip the inequality symbol. Greater or less than. I purposefully misspell them to help me to remember if it's going to be an or compound inequality or an and. Okay, let's practice using this rule. So at the top of the next page, I'm going to write that memory word that helps me remember, is it going to be an or situation or an and? So I misspell greater and I say greater, and then I misspell less than and just add a D next to it. So let's see how number 1 and number 2 would differ. It says solve the following, graph your answer, and list your answers in interval notation. So looking at number 1, I know in order to remove those absolute value, I need 2 situations. There's 2 distances away from 0 on the number line. Is this going to be an or situation or an and? Or, good, because this is a greater symbol. So this is going to be an or.
Greater is facing forward, it's like the
If it's
absolute
facing,
value.
then it's a less than. If it's facing away
What
from
makes
the,
it an or?
if it's a greater symbol. So this is a greater.
Oh,
if
if it's
it-
greater than or equal to, then it's an and.
No, it's still an or. This would be an and if it's facing towards the absolute value.
Oh, that's what I was saying, like if it faces like the absolute value.
Yes, the absolute value is where you want to look from.
Yeah.
Good. So we would put an or here, and then we're going to use kind of what we just saw. Copy exactly what you see without the absolute value. X minus 2 has to be greater than 4. Just so you guys know, I always put that one on the right because then it matches the number line. The other one we're going to copy without the absolute value, but I'm not going to copy the symbol. What are you going to do with the symbol? Flip it, and what are you going to do with the sign of the number? Make it negative. And then you solve for each of these. So I'm going to add 2, and that tells me that X has to be less than negative 2, or add 2, add 2. X has to be greater than 6. So now I'm going to graph these answers on the number line. I'll have an open circle at 6, an open circle at -2. Why did I say open circle? Good, it doesn't have an equal bar. And then how am I going to shade in the direction from -2? Where it's pointing. So where is it pointing? To the left. Good. And then how about the number 6? I have an open circle, and which way am I going to shade that? To the right. Good. Now in interval notation, this is how you had to label it on the quiz. What's the smallest value X could be? Good. And where does it go up to? Good. Should I have a parentheses or a bracket? Good. And then to join two sets, we do a union. And then what should I have around the number 6? Parentheses. Good. And what's the highest value X could be? Infinity.
Sorry, 7 or 6.
Keeps going.
Never mind, never mind.
Infinity.
I was seeing numbers. I was like.
You were testing me. Thank you, Caleb. Just saying numbers. All right, guys, looking at number 2. Number 2, is this going to be an and situation or an or situation? And good, because it's a less than symbol. So I'm going to put the word and then I'm going to use what I know to be true. Copy exactly what you see without the absolute value. So X minus 2 has to be less than or equal to 4. And copy the numbers and the variables that you see. But what are you going to do with the inequality symbol? Switch it, and what are you going to do with the number? Make it negative. Good. And then you're going to solve for each. So I would add 2, which gives me X has to be greater than or equal to -2, and add 2, X has to be less than or equal to 6. This is an and situation, so I'm not going to keep going on the number line. I have to make the numbers fit both inequalities. So the values of X have to be bigger than or equal to -2. So I'm going to have a closed circle at -2, shading to the right. But where am I going to stop?
At 6.
At 6, good, because it has to also be less than or equal to 6. And then what would be my answer in interval notation? Nice. And that's it. Okay, let's do a few more together. Looking at, so I could box that too, and that's my answer. The next one's a little bit different. What do I have to do? Divide by 3. Good, because it's being multiplied by the absolute value. So we got to eliminate that.
I know my brain thought that was like number 3.
Yeah, I think I accidentally put a space there. It was supposed to be like right smushed up next to it. But, you know, I'm testing you at the end of the day. All right, now we have the absolute value of X plus 1 is greater than 2. I'd like you to turn to your partner, this time the person with the shorter hair. You share how you would go about solving this.
I think that is sort of.
Caleb, you're with Michaela. So you gotta tell her, what would you do?
Okay, you would, so, let me see. Okay, so you do X plus 1 would be, I can't see how. Over.
That's it. So we divided by 3.
You divide by 3.
Good.
And it'll be 2.
Good.
And then, X plus 1 is greater than 2, so you subtract the 1. And you
Okay.
have to also like switch it, don't you?
Well, you're solving, you just told her to solve for this. You got X is greater than
And
1.
then don't you like switch the inequality sign?
Yes, for the other one, you're gonna switch the
Then
inequality
make it
sign
negative.
and make it negative. Nice.
And then you subtract 1.
Good.
Thank you so much. Oh my gosh.
X is less than -3. Is this an or an and situation?
In the over. Yeah, because basically.
Good, because it's a greater than symbol. Greater. And then if I graph this,
So will the absolute value always be on the left side? It could be on the right.
it could be on the right side, but it generally shows up on the left. If it is on the right side, I would just say move it to the left. So this greater or less than thing can keep working for you. I think in every question I assigned, it's on the left. All right, I'm hearing a lot of silence, so I'm assuming you guys are finished. Did you have an open circle at 1 shading to the right and then an open circle shading to the left? And because this is an OR situation, did you say negative infinity to negative 3 with parentheses, union with parentheses 1 to infinity? Yeah, did we get it? Any questions so far? All right, let's try the next one. The next one, the absolute value is already by itself. So how do you undo an absolute value? We can't until we undo the absolute value, which is a really good thing to be aware of. You need to undo the absolute value, then you can start working with it. So how do I undo the absolute value? 2 equations, good. So I'm going to copy exactly what I see to the right without the absolute value. 2/3 t plus 1/2 has to be less than or equal to 1/6. What do I have to do with the one on the left? Put a negative, good, and do what with the sign? Switch it, good. So it's going to be a greater than or equal to and a negative 1/6.
Would you multiply each side by 3/2?
Not yet. I got to undo that absolute value. So the only way to undo that is to break it into 2. Then it's a less than symbol. So should it be an or an and? Good. Now I'm going to solve for both of these. We've worked with fractions in the past. What's a nice, easy way to get rid of all the fractions? Least common denominator. What would be the least common denominator? 6. Good. So I'll multiply this side by 6 and this side by 6. I'm going to start with the right side because it's easier. What's 1/6 of 6?
6 is 6.
Let me ask you this. Yes, it's 1. How many times does 6 go into 6 evenly? 1. So this is just a negative 1. I probably said that weird. And then distribute it in. How many times does 3 go into 6 evenly? 2. So I have 2 times 2t plus, how many times does 2 go into 6 evenly? 3. Good. And we got rid of all the fractions. So now I have 4t plus 3 is greater than or equal to negative 1. And then I subtract 3. So I'm going to get 4t is greater than or equal to negative 4. Divide both sides by 4. And I get t has to be greater than or equal to negative 1. And, well, let's do the same thing we just did on the other side. So what should we multiply everything by? 6. And this ends up being the same equation without the negative. So I'm going to have 1. When I distribute here, I'm going to have 3. When I distribute there, I'm going to have 4t. Allison. Ooh, if it was a negative 4, I would totally flip the sign. And it's always something good to think about. But because it was a positive 4 we're dividing by, we don't flip the sign. Okay, then we would subtract the 3.
Where did you get the? The green one is with the red one.
Yeah, the blue one's with the left, and then like this is trailing here, and then I'm completing that one on the right.
How did you get?
1.
Yeah.
I multiplied both sides by 6, and then I said how many times is 6?
How did you get t?
So were you here?
Yes.
Okay.
I do it a different way. That's like I just do 6 times 2 divided by
6 times 2 is 12, divided by 3 is 4.
That's how I get that.
And then 6 divided by 2 is 3. And then you should have negative 1 over here.
Why is it negative 1?
Because when we set up both equations, you have to flip the sign, flip the sign.
Okay.
Yeah. And then over here, we would get is less than or equal to negative 2. And then we divide both sides by 4. And we get t has to be less than or equal to, what is negative 2 over 4 reduced to? Good, negative 1/2.
I did that.
Okay, so cleaning this up, I should say t has to be greater than or equal to negative 1, and it has to be less than or equal to negative 1/2. Oh, you forgot to
I
put,
forgot to flip the sign, so I got 2/4 the first time.
Got it, got it.
So the range.
Okay, so if t has to be greater than or equal to -1, are we gonna have a closed circle or an open circle at -1? Closed. And where is it going to stop at?
Negative one.
-1/2. Awesome. So I'll put like a 0 here to show that it's going to stop halfway between 0 and -1. And then would I have a bracket or a parentheses around -1? Bracket. And then what would I have around -1/2? Bracket. Nice. And that would be my answer. Okay, looking at the next one. Those of you who are more visually minded, maybe the more artistic in the crew, might look at this question and say, I already know what the answer is. So let me give you those who are more visually minded just an opportunity to do that. If you're saying I have to solve for x and the distance away from 0 on a number line has to be bigger than or equal to -2 units, what types of numbers are going to be bigger than negative units away from 0 on a number line? Ooh, who said it? Michaela. Nice. Everything. She's right. Everything is going to be bigger than negative units because everything is more than negative values. Now, if you were like, wow, I didn't see that, you could actually go through the algebra to be able to determine that it is everything. So let's go ahead and let's just go through the algebra so we can see it. So using what we know, is this going to be, it's a greater than symbol. Am I going to have or and? Or, good. Copy what you see. 6x plus 3 has to be greater than or equal to -2. Or 6x plus 3 has to be, what do I have to do? Switch the sign and switch the sign of the number. So the opposite of -2. And I'm going to solve for both. So if I solve for the one on the left, I have 6x plus 3 has to be less than or equal to 2.
If it's less than or greater, if it's less than.
Then it's an
or
and.
equal to, it's always.
Yep.
But
If it's greater or greater than or equal to, it's always an or. Good. Okay, so then we'll subtract 3. And we get 6x has to be less than or equal to -1. Divide by 6. So we see x has to be less than or equal to -1/6. Or we subtract 3. And we get 6x has to be greater than or equal to -5. Divide by 6. Or x has to be greater than or equal to -5/6. If I graph these values on a number line, you will end up shading everything. Exactly right. Because if I look at 0 and then -1, -1/6 would be 1/6 of the way to -1. And I would shade everything less than here. -5/6 would be more closer to -1. So like right here. And I would shade everything this way. Exactly. So if I'm asking what number makes one or the other one true, you might be looking at the number 0 and being like, well, wait a minute, 0 doesn't work for this one. It doesn't, but it does work for this one. So every number works for one or the other. So our answer is everything. -infinity to infinity makes this inequality true. And if you're looking at algebraically, every number works for one or the other inequality.
Why is it foldable?
Because every number works for one or the other. So I have to shade the entire thing because everything less than or equal to -1/6 is this way. And everything greater than or equal to -5/6 is this way.
Okay.
And it's not an and. If it was an and, just stop them.
Okay.
Question. Allison.
Does this apply for all greater than measures?
Yes. It's
Does it apply for the less than?
Let's think through it. So here's the less than. Okay, so those of you who are more visually minded, you might already know the answer to this next one without having to do any work. If you're asking the absolute value, that means the distance away from 0 on a number line. What numbers have distances away from 0 that are less than -4 units? What'd you say? You're right. Are you an artist? Well done. Nice job. Very artistic. You're a deep thinker. It would be nothing because there's nothing away. There's nothing that's less than negative units from 0. Now, if you didn't think like Michaela did, you could go through the algebra and at the end be able to determine that nothing will work. So I'll quickly show how this shows that nothing works because we copy exactly what we see. 7 minus 8x is less than negative 4. This is an and situation. And 7 minus 8x has to be flip the sign and flip the sign. So greater than the opposite of negative 4. So I have 7 minus 8x has to be greater than 4. Subtract 7. And I get greater than negative 3. Divide by negative. Allison, what do I have to do if I divide by a negative? Nice. Flip that sign. 3/8. And I know I'm working fast through this because I'm just showing you guys the algebra. Negative 8x has to be less than negative 11. Divide by a negative. When you divide by a negative, you have to flip the sign. So you're looking at what numbers have to be less than 3/8 and bigger than 11/8. 11/8 is the same thing as 1 3/8. So if I was trying to graph this, you'd have 3/8 is smaller, 1 3/8 is bigger. What numbers are going to make both of these true? Is the number 2, that's shaded, is that bigger than 1 3/8 and less than 3/8? No. So there's nothing that can make both of those true. No number will fit both conditions. All right. You guys